Today I'll show you everything you need to know about the builder design pattern. It's a creational design pattern and it's quite popular. The purpose of the builder design pattern is to separate the construction of a complex object from its representation. Let me show you what I mean. I'm going to create a class, carOffer. This class will have a lot of fields. For example, a string field for the model name, and a few Boolean fields for the car features. A field for the cruise control, a field for the sunroof, a field for the four-wheel drive, and a field for the heated seats. Also, let's create a constructor with all the fields. And next, I will create a class application and a main method. Let's create one car offer. I have to provide the model name and all the car features. Okay, we have a car offer. And actually, the code doesn't look so bad. But the reason for this is the IntelliJ feature that shows us the names of the parameters, and it makes the code understandable. But not all IDEs have this feature. Also, you can be looking at this code in a source control system and you'll not have such hints. Now, looking at line 6 is not very readable, right? Is this car four-wheel drive? Well, I have to first check which of these arguments is for the four-wheel drive feature. And this class has only 5 fields. What if there are 10 fields? You can't really understand the properties of this object unless you inspect the code. Let's talk about a different scenario. What if you don't want to specify all the fields of this class? For example, you want to provide only the model name and some of the features and assume the other features will be false. We can achieve this by creating a specific constructor for our needs. Let's create a constructor that will assume some of the features to be false. For example, the sunroof and the four-wheel drive features. And instead of duplicating the code, we just call the other constructor. Let's create one more with only the model name as a parameter, and all the other features will have predefined values. This constructor will call the second one. Now I can create the same car offer as before by calling the new constructor with only the model name parameter. This technique is called telescoping constructor pattern. The class has numerous constructors, each one taking different parameters. This allows you to create instances with the correct combination of parameters on each situation. However, this means that you must remember the required order of the parameters as well as what particular constructor you might want in any given situation. There is another solution, and it's called builderpattern. It gives us a lot of benefits, but let's first implement it and then we'll talk about them. Let's clean up these constructors and create a new static class builder. This class will have the same fields as carOffer. I'll copy and paste them, but I will remove the final statement because we want to be able to set their values. Let's change the constructor of carOffer. Instead of passing all fields as parameters, we're going to pass only the builder. And then the carOffer fields will be initialized by those from the builder. Also, let's change the visibility of this constructor to private and create the new method build, which is going to call this constructor. This will be the only way to create instances of car offer. The workflow will be: first you create a builder, second you set all the properties of this builder, and then you call the build method and you receive a car offer object. Now we must add setters in our builder. The IDEs are usually pretty helpful with this. In IntelliJ, I can automatically generate the setters. I have two templates, one for the normal setters and one for the builder setters. I choose the builder setters and they're generated. Builder setters are the same as normal setters, but instead of returning void, their return type is builder. The reason to return builder is that this way you can call setters one after another, like a chain. I create the builder and then set the model name, then set heated seats, then the sunroof, and so on. Finally, I call the build method and my car offer object is completed. One more minor change. I'll rename the setters. Let's remove the set prefix. We know this is a builder class and we know these methods are setters. I think it's more readable without the set prefix. And this is our final version. It is certainly more understandable than the constructor on line 8. Just looking at this code, you know exactly what car offer you're creating. Let's talk about the benefits. The first one is encapsulation. The builder pattern encapsulates the code for the construction and the code for the representation, and this is very useful when we deal with complex objects. Next, the builder pattern gives control over the steps of the construction process. Because of that, instances are always created in a complete state. Also, because of this, we can easily create immutable classes with a large set of state attributes. And last but not least is the readability. I know the number of lines of code increases at least to double in the builder pattern, but the effort pays off in terms of design flexibility and much more readable code. Builder pattern is commonly used and every programmer should be familiar with it. I hope you enjoyed the video, and if you learned something today, please subscribe to the channel.